Models are advanced AI systems designed to understand, generate, and interact with human language at an unprecedented scale. The launch of ChatGPT in November last year was a watershed moment in the evolution of artificial intelligence. Its ability to generate coherent and contextually relevant responses opened the doors to numerous applications, from customer service automation to aiding researchers in information synthesis. McKinsey estimates that the use of generative AI can add up to 4.4 trillion US dollars to the global economy every year. However, the development of large language models faces significant challenges in a multilingual world. While they excel in languages with extensive online resources, like English, they often fail in understanding and generating content in less represented languages. This limits the utility of LLMs in multilingual countries and raises concerns about linguistic and cultural biases. Today's discussion will aim to unpack these challenges and deliberate upon strategies to democratize language models. We are joined by a stellar panel of experts working on the cutting edge of this technology. I would now like to call upon the stage our panelists for today, Mr. Amitabh Nag, CEO of Digital India Bhashini Division. We have Professor Mohit Bansal, John R. and Louise S. Parker Professor, University of North Carolina. We have Professor Mitesh Khapra, Associate Professor, Department of Computer Science, IIT Madras. We have Mr. Americo Carvalho, Head of AI and ML at Amazon Web Services. We have Dr. Rohini Srivastava, Chief Technology Officer for India and South Asia, Microsoft. Dr. Vinod Kumar Prabhakaran, Staff Research Scientist and Lead Technology, AI, Society and Culture at Google Research. Mr. Manohar Paluri, Senior Director, AI at Meta. And Ankita Sharma, Segment Leader for Conversational AI, NVIDIA. So before we begin, I think we will get a group photo. Can you change the backdrop? And without further ado, I would like to request Mr. Amitabh Nag, CEO of Bhashini, to take over the proceedings. Sir.
Thank you. Thank you to everyone for being here, especially the panelists who are traveling across from, multiple locations to be here. And, there has been a lot of enthusiasm of LLM or large language models for last, so many months as we go by. And often it is talked about as what is good in language may not be good in knowledge, and what is good in knowledge may not be good in language. But LLM is all about good in language. And about the knowledge, there has been always a question marks which are raised. And often it is talked that it's a function of data and how well you train the child. The child is going to, grow up into a good adult or a bad adult or whatever. And so there is a lot of responsibility which the cohort here has who are interested in this particular topic. And we are here to discuss how do we create a large, scalable LLM, especially for the countries which are multilingual, and that is one of the aspects which is there. We also have the challenge of digital divide and literacy divide, and as you know, as Bhashini, we have been using voice as a medium to cover that up, and there are a lot of things which has been done by Bhashini, and Professor Mitesh has been a part of it to come over that multilinguality part of it, but still we have to do a lot more, and that is where we are sitting out here. Without further delay, I would like to invite Professor Mitesh Khapra to deliver the keynote address. He has been working with the Project Bhashni for very long. He is heading the data management unit and has dabbled with these technologies. And I would like you to talk about it as well as the, how to tackle the multilinguality of it before we throw the session open for the other panelists to react to specific topics which we have. Professor Kaplan.
Hi, everyone. Thank you, first of all, for inviting me here, and a pleasure to talk here. So what I'll do is I'll give you some perspective on how Gen AI, at least in the context of LLMs, right, is very different from what it is in the English world, right? So first, let me sort of introduce you to the English world, right, where all of us probably have played with this chat.openai.com, right? And of course, when it comes to the English world, I'm going to exaggerate a lot. And when it comes to the Indian situation, I'm going to underestimate a bit, right? So that gap becomes very clear. So when you talk about the English world, right? So what do these LLMs get powered by, right? They get powered by a large amount of text data available on the internet, right? And a few very simple statistics here. If you look at Wikipedia, there are order 6 million articles in English and order 1 lakh articles in Indian languages, right? So there's a huge gap there. And these Wikipedia, if you look at it as a repository of knowledge, there's a huge knowledge base available for English readily to feed to large language models, whereas for Indian languages, we are lacking behind, right? And it's not just that. If you look at any of the powerful open source LLMs which have declared the amount of training data that they use, they train on something known as 2 trillion tokens, right? And just plain words, it means that you think a large piece of text which has 2 trillion words in it, right? And these 2 trillion words cover different domains like health, agriculture, politics, science, all of it, right? You can think of all the world knowledge is encoded in them, right? Now, if you look at Indian languages, there isn't so much data really available in Hindi, right? It's order billions of tokens and nowhere close to trillions of tokens, right? So this is one major difference from the English world, that you already had this data lying in. All you needed to do is build a technology like GPT-4. As I said, right, I'm exaggerating saying that all you needed to do. Of course, it's hard. Of course, it took time to get there. But then you could focus on that problem. You really did not have to worry about the data problem, right? And once you build this technology, you have a large number of users who are familiar with the English world, who have been using the English keyboard for ages. They don't have any problem. All of us, right? We just go and log into chat.openai.com and start typing in English. We have absolutely no problems in doing that, right? So users are already trained to explore English interfaces, right? They're already comfortable with English interfaces. And of course, there are a gazillion benchmarks which exist on which you could evaluate these large language models and say that, hey, on these tasks, now we are close to human performance. On these tasks, we are lacking behind. And these are a new set of innovative tasks that we have come up with, right? And a lot of new tasks got created once ChatGPT was exposed publicly to the world, where people started interacting with in various creative ways and say that this is the task I want, can you solve this, right? And all of this is now possible to evaluate in the English world, right? But now, if you come to the Indian world, right, how do you make this success happen in the Indian world? And that's a long journey. You can see that the slide is blank now, but don't worry, I'll fill it up. So you need a lot of tools for manual data collection, right? We, as a part of the Bhashini project, this is an ambitious project set up by the Ministry of Electronics and Information Technology. There is a huge plan to collect data for Indian languages across modalities, text and speech for now, and also a little bit of image data, right? But still a lot needs to be done. And once we scale this up, we'll have a lot of context from Indian public, right? Which talks about their experiences, their folklores, their world knowledge, which can then be fed into large language models. Such a repository, knowledge repository of India does not really exist in digital form. All of us know there are many libraries in which data has been locked, right? It's available in textbook form or in the form of non-machine readable content. That needs to be unlocked, right? Imagine every library in India getting digitized to unlock all the ancient knowledge that we have in our knowledge system, right? So that effort is needed at scale. Almost think of it as a very large infrastructure which needs to be set up across the country. That is for manual data collection. There are also several sources of data readily available on the internet. There is web, no matter how small it may be for Indian languages, but we have not fully exploited it yet, right? We need to go and crawl all the content. The government again has done a fantastic job of having so many good websites on culture and Wikispedia and other websites, right? But they are still not completely consumed and fed to these modern large language models, and we need to build the pipelines to feed them. Think of our own broadcast services, right? Like Prasar Bharati, All India Radio. All India Radio, every day, it has a broadcast, it broadcasts 3 bulletins every day in 40 plus languages, right? And these are news bulletins where a person is talking and the transcript is also available. Can we collect this for the past 20 years and feed it as Indian knowledge to these large language models, right? So many people now upload content on YouTube, our recipes, our take on Chandrayaan. The moment Chandrayaan was launched, if you go on YouTube, everybody in every language, there were thousands of people who wanted to say something about it, right? This is going from very laymanish, that we are very proud and so on, to very technical descriptions of what the mission involved, what was the team size, what were they doing, how did we succeed and so on, right? Can we capture all that knowledge by extracting data from these videos which lie on the internet, right? And similarly, a lot of data is logged in PDFs, which has a long legacy to it, right? Supreme Court judgments, for example, is one such database of Indian-specific content, and many other government websites have this. So can we create these data pipelines so that using all of this, we can build our Sangraha, which today does not exist. Sangraha, think of it as the knowledge repository which represent India, right? All our Indian knowledge system can be put into this one database, which can then be used to train a large language model, right? But unfortunately, even if we do all of this, the story still does not end there. And I'll tell you why, right? When an Indian user comes and interacts with LLMs, most of us will not type in our native languages. We can't type in Devanagari, we can't type in Tamil, we can't type in Telugu. We are used to the English keyboard and we prefer Romanized inputs. Unfortunate as it may be, many of us are not even very comfortable with spellings in our native languages. The difference between a Raswa E or a Dirgha Hi, the small vowel versus the bigger vowel, is often not clear to us, right? So we may just prefer to talk with the LLM in our voice because we can speak our language, no matter how imperfect it may be, but we can speak it. So just building an LLM is not enough. You have to focus on this more foundational technology of building speech recognition for Indian languages so that humans can interact with them. Similarly, you will have to build what are known as Romanized keyboards. The technical term for that is transliteration. That's what's written on the slide. Because we always, when we chat on WhatsApp and other places, we always type in Romanized context. Most of us type in Romanized. Although I'm talking in Hindi or typing in Hindi, I will not type Gh and R, I will type Ghar for Ghar, which is house in Hindi, right? So we need to have interfaces which can work with this Romanized content. Next, no matter how much data we collect, right, for the foreseeable future, a large amount of the world knowledge would still come from the English data, and it is possible that the LLMs that we build are better off in English than our own languages because the data is a bit skewed, right? I'm not saying that collect all the data which I've shown on the right-hand side, but throw away all the English world knowledge. No, you'll feed that too, right? And since that is still going to dominate, you might want to translate the input needs, the user's queries, and then interact with the LLM while also feed the original query that the user has provided, right? And before doing all this, of course, you need to build toxicity detection, right? That is one of the major challenges where LLMs get abused, and you need to do something about it in the Indian context. I think there's a question on that in the panel discussion, so I'll not go into more detail of now, but I have things to say about that. Now, similarly, once the answer comes back, you again need to synthesize that in Indian languages and optionally also translate before synthesizing it, right? So it's not just about building LLMs in India, it's like starting ground up where you collect a lot of data for all this foundational technology, collect a lot of data for the modern LLM world, synthesize all these technologies together into one system which can work seamlessly in a multilingual context, understands multiple languages, can speak in multiple languages, can translate, can look up the LLM for reasoning and so on. Right? So this entire picture needs to be created, and that is definitely much more complex than the small picture that you see on the right hand, on the left hand side at the top, right? So all of this needs to be done in a multilingual country like India, and efforts like Bhashini and others would really go a long way in enabling this, right? So I'll end my talk here, and of course I'll join the panel for more discussion. Thank you.
Thank you, Professor Mitesh. And data is one of the important aspects of LLM. But just taking the topic, slightly away, and talking to you, Professor, Mohit Bansal, it's about, there are a lot of research works which are going on in this area, and being part of many of them. Would like to know what are the various avenues of AI, research in AI, research in LLM, and research in NLP technologies which are available, which were going to impact all this which we are talking about the diversity, about the cultural biases, about various type of data, etc., etc. So, if you could throw your light on that.
Hello, can you? Okay. Yeah, thanks. Thanks for the great question, and thanks, Mitesh, for a nice summary of the challenges and the opportunities that lie ahead. So I'll keep it brief because we have a lot of questions and a lot of great panelists. So, so in terms of opportunities or things that AI, we are already seeing very good use cases for, right? I'm sure you've seen a lot of things around you, all the way from better chatbots, right? For even things like personalized customer service. There's a lot of impact already in things like education, right? The dream for a lot of people, including, for example, Sal Khan from the Khan Academy, is about personalized tutoring, right? One-on-one tutors for kids. There's a lot of work that's been done for things like getting into healthcare, molecule drug discovery, right? Automatic drug discovery, finding relations between different kinds of drugs and molecules. So it's an endless road to opportunity. But like you said, at the same time, there's a lot of challenges as well as risks that we need to be aware of. So in terms of missing data, right, that's one probably big topic for today. What could we do? What are the challenges as well as opportunities? I think basically there's a lot of opportunity in multimodality personally, right? If we can connect multilinguality to multimodality, and by that I mean you could use images, videos, documents, right, which Mitesh also referred to as other modalities, right? Because as humans also, right, we use a lot of our joint senses when we are using these modalities as bridges, right, between languages. It can give you some extra context, right, that may not be either available or sometimes it's actually not supposed to be available because some things are better said in language, some things are better seen visually, right? So different modalities have different purposes. So that would be one thought that we can expand on later. And also I feel like culturally, right, since you brought up this question very importantly, cultural biases, I think again, the other modalities could help you sort of resolve certain biases that only one modality might have, right? Because you can actually figure out that, wait, I misunderstood this sort of cultural bias here, whereas when I have another modality like an image, I was able to actually correct my bias. So we've been focusing a lot on unified models, which means basically they work with audio, text, vision, like images, videos, documents, right? All of these together as a unified input and output paradigm where you can basically combine any kind of inputs and try to generate any kinds of outputs together, such that there's three advantages, right? Shared knowledge between these modalities, a general architecture, right, instead of specialized architectures, which is very infeasible, right, resource-wise. And third of all, it's also very efficient. You can actually get n times less parameters, right, but the same number of capabilities. And then on the risk side, we'll probably cover a lot of this today, is about the data should also not be coming with its own bias, right? So there's missing data, but sometimes if you get tempted and use the wrong data, right, then it can insert a lot of biases into your models. So there's a lot of obviously work there on first having the data itself be clean and representing diverse opinions, which is very, very hard to scale. So then should we do that as a sort of automated way or semi-automated way, or could we do it in a post-processing way where can we edit the model and remove certain biases without retraining the model? So there's a lot of work going on now on model editing. Can we figure out where the biases are stored in the model, which is very challenging. But even when you figure it out where it's stored, it's not easy to actually edit or delete the knowledge based on that localized information. So I'll probably pause here and then.
Yeah, just one supplementary question to that. There is a lot of debate about one large language model versus narrow models. What's your view on that, and where is the research going in that?
So I was actually just answering this exact question at the NLP conference that we just came from. So my opinion here is that it should not be one large monolithic model. When I say unified, it's more about having modules, right? So you basically should have a library, think of it as a library of skills, right? Even when we code, right, we import different kinds of libraries. So I imagine it as having modules or libraries for different kinds of skills where different LLMs already exist, right? There might be a very strong state-of-the-art LLM for video and language. There might be one for multiple languages, right? Maybe 30 languages that can be handled together. Then someone else makes a language model for another set of 25 languages, right? But they don't overlap. So these would be modules, and then the language model's job should be able to program or plan over these modules and figure out for a new unseen task, which could be a new translation task or a new video to, say, text translation task, right? Language to language translation, image to language translation. It should be able to figure out which modules should I use from my library and in which order should I combine them. And then maybe there'll be a last challenging step where sometimes none of these modules are enough. That's where another power of the LLM should come in to decide which module should I grow and expand, right, to bring in these new capabilities. So that's sort of the final challenge of unseen generalization or compositional generalization. So my opinion is that it should be a skill of libraries or modules where we can take all the state-of-the-art LLMs that already exist, right, and we keep adding to that library when things keep getting better in terms of state-of-the-art, and we don't basically use it as a monolithic structure, but try to learn combinations over these.
Yeah, thank you. Thank you. I think, some, deep thought views around it, and, we will, perhaps the other panelists can also, give a view around it once their chance comes. But I'll just move on to another question, and perhaps, Rohini, this is directed to you, is that, there is, you people have been in the thick of the innovation which has happened and the challenges which has happened around that innovation. So how is this, give a view on how is this shaping for the industry? What are the various use cases you see? Does the negative thoughts which are around this, how are you guardrailing them? And how do you, taking this business forward so that, people are able to know how good or bad this technology is?
So let me start by first pointing out that the large language models, which we call, at least the one that is called the generative pre-trained transformer, the model, it's the paradigm shift is important to understand. What I mean by that is the way in which previously machine learning models used to work, that you would train a model for a specific task, let's say for language translation or for face recognition. You would use that model for that particular task. You did not use that model for other tasks, or you do not expect the model to work for other tasks. The paradigm shift that has happened with these LLMs is that these have become foundational models. What that means is they are able to perform tasks beyond what they were trained for. That paradigm shift changes a few things. First, it changes that you don't always, in fact, you are not encouraged to use its internal knowledge representation. What you do is you actually have an orchestration layer on top of the model, which brings in knowledge from domains, gives it to the model to reason and create output in natural language. Let me give an example. If any of you have used Bing Chat, which is a search engine, and it's a chat on top, what is it doing? When you ask Bing Chat, what is the weather like today in Delhi? It is not asking the large language model what is the weather in Delhi. The large language model has no idea. What it is doing is, it is throwing a query to a search engine, which has information about weather in Delhi as of today. It is orchestrating that information to give to the large language model that is then able to respond to you in natural language. So that fundamental shift of how you use these large language models is an important one to grasp, because then you start to think about how are you going to use it for different use cases. Now, the places, to answer your question, Amitabh, the places we are seeing this is in this whole area of augmentation. And by that, I use the term co-pilot. Let me give an example. If, let's say, you are trying to do you're trying to write something that is a new essay or something. Your ability to give the context to the model, let's say you're writing on, I don't know, Indian handlooms. Your ability to pick Indian handloom information that the model doesn't know. Don't expect the model to know about Indian handlooms. That is the paradigm shift. You take information about Indian handlooms, you give to the model, that's the orchestration layer. Then you work with the model to create something for you that is in natural language. So if I go into different use cases, for example, today if you are using Air India and you're trying to book your reservations using Air India, its chatbot, it's using OpenAI underneath. How is it doing that? It is not, the OpenAI chatbot, OpenAI model doesn't understand what Air India does, but it has context, the grounding is given based on Air India's latest offerings, what are the schedule changes, what are the options. That is then given to the large language model to then provide a natural interface to the customer. This you can now replicate across industry use cases. Look at, for example, hospitality, look at Make My Trip, look at travel industry. Any of these industries, in fact, today you have an ability to create a chatbot for your website literally in one click, because its ability to ground the data based on the website and be able to ask questions. So I think that paradigm shift is important to understand. And I'll end with the point. I think I first of all love what Mitesh was talking about in terms of the Indic language corpus of data. I think that is very, very important. But it's also important to realize, to the point I'm making earlier, is that the way today you use these large language models, and of course we should create one. Of course it is important to make sure that India's knowledge language is incorporated into something that is going to be considered as intelligence, right? That is superbly important. I totally understand that. But today, if you were to say, if you follow my point about the paradigm shift, and you are very familiar with the Bhashini world, how did the Jugalbandi chatbot work? What the Jugalbandi chatbot is doing is that it is using the PM Kisan Yojana corpus that is given to the OpenAI model. The OpenAI model doesn't understand what PM Kisan Yojana does. But your ability to query the context by giving the context of PM Kisan Yojana to the OpenAI model and query it using Bhashini as language is then allows the model to give you information that is grounded on data. That's the paradigm shift I wanted to call out in terms of our understanding how this is different from machine learning of the past decades.
Right. Thank you very much, Rohini. And, you know, obviously we are seeing a lot of use cases which are, you know, bringing up inclusive society, because you are now able to query using the natural language and are able to find a lot of things. Americo, you have been involved in a lot of, you know, machine learning, you know, research otherwise also. What do you think the world of NLP is, which way the world of NLP is going in the world of this large language models, you know? Will there be more solutions which we will found? How will this impact, the large language model research or the usage, or it will aid to it? And what are the different solutions which you see coming up in the future?
Sure, thank you. And first, super excited to be here. Thanks for the opportunity. Yes, thank you. So first, super excited to be here today, and thank you for the opportunity. I'd like to come back just a bit on the comments that have been done by the two professors here as well, in terms of the challenges for the Indian languages. We do recognize, and that's something that we observed across the board, and again, my view is much more practical, observing how public sector customers are right now interacting with generative AI and dealing with the large language models. So the question of language is something very common in Europe, for instance, which have a lot of fragmented languages. There is also this Chinchilla law, which basically states that for one parameter, you need roughly 20 tokens tokens to train the model. So that really gives us a sense of the magnitude of the data that is required if we want to train just 100 billion parameter models. On what has been commented also on the, what's the future, what's the use cases look like, and how many large language models are we going to use, either a big one versus a multiple LLMs. We do see the trend with our customers that even for very basic use cases, they recognize that there are hundreds of different LLMs of different size, of different skills, and even a very simple use case can very likely articulate many of those LLMs. Because of course, depending on the use case, depending on the step of the use case, you don't necessarily need the same skills. You don't need the same size of model. When we talk about large, very large models, for instance, they also come with a cost. This cost could be in terms of latency or just the cost that basically the model provider is charging for the usage. So back to your question now, what we are seeing across the board in public sector is definitively more than just new technologies, keeping humans in the loop to help adding skills to those models in terms of different types of languages. It's also more and more leveraging the opportunity to use continuous fine-tuning and continuous training, even for the large language models that have been pre-trained on very large data sets. They need to stay connected with the actuality and reflect that to the use case. So when you start combining human in the loop and those kind of technologies, that really starts giving you an edge on how you could tackle adding additional languages to those LLMs.
Thank you. One of the things which have been talked about, and this perhaps I would direct it to Dr. Vinod, is, since broadly the open source has been a buzzword, and you guys have been quite working on the open source part of it, how does this approach help, and does it help in the LLM world? How does it foster collaboration? What have been your experiences around it? So it's a question of the approach which, overall building a scalable, LLM people should take.
Thanks for the question. And I'm happy to be here, and thanks for the invitation as well. So, before I get to the open source question, I think I want to start by sort of like acknowledging like the capabilities that have just sort of like these new recent technologies, like recent advancements in LLM technologies have like enabled us to do. And in doing that, like the open source kind of ecosystem provides a way to sort of accelerate that in scope and in impact in a multitude of ways. And when I think about open source, especially in these kind of technologies, large language models, I think of them as like a dual use technologies, like that they can have like potential kind of misuse and malicious use cases. And this comes from the fact that like I work in a responsible AI organization, and I think about those aspects of like sort of side effects or things that we don't really foresee. And those issues become like a lot more challenging in an open source setting. So I personally do not have like a strong opinion of like in favor or against open source, but I do recognize that it is very it does accelerate the scope and impact like very quickly. But I'll stop by also saying like a few words about the responsibility angle, because like that's important even when you because whether Google or other any particular entity decides to open source their models or not, and there are definitely going to be open source models that are out there, and they are improving in their performance like by the week. This morning I saw a new open source model has come out which has matched the GPT 3.5 performance, I believe, in whatever benchmarks they were talking about. But in all those contexts, I think the responsibility aspects of this is super important, and that there are challenges around the data that folks talked about, but also model interventions, and there's a lot the open source community can do in there, because individual companies or entities may not be able to completely solve these problems, because especially from a responsible AI standpoint, a lot of these are social or societal kind of knowledge that is important to intervene there, and you'll need a larger a collective effort to intervene there. I don't know if open source, the way we conceive it right now, is necessarily the framework that would be the most effective and safe way of doing it because of the concerns that I mentioned. But I think of it more as community engagement. There are other avenues of community engagement that can address some of the gaps in data, address some of the gaps in societal knowledge that will be important to expand these technologies' scope and capabilities in a safe and responsible way.
Thank you. I think, yes, responsible and ethics become very important for that, and that brings me to the next question, Manohar, if you could help me around it. It's, regulation, ethics have, been under discussion for LLM for quite a long time. Long time means ever since last few months, and it has been long enough because there has been a lot of discussions around it. So what are your views on that? How regulated it should be? What way in which we can, leave it for ethics to be followed, a self-regulatory mechanism? What are your views on that, and how will it, increase proliferation of LLM, or, for example, stop the proliferation of LLM as it goes by? So, people are today hesitant to use it, but some people want to use it because there is a technology which is available, and it should be used, right?
Yeah, thank you for having me here, and I think it's a great question. I like to think of past examples rather than trying to reinvent the wheel. So if you look at what Meta has done historically, all the way going to Open Compute, which is the hardware revolution of building the most efficient data centers, that wouldn't be possible if it was taken as an initiative by one company. If you think about the ecosystem that we evolved in machine learning with PyTorch, that wouldn't be possible if it was one company pushing the PyTorch ecosystem, all the way from hardware integrations to software optimizations to developer ecosystem, and what new kernels need to be there, what additional software packages need to be there to proliferate machine learning. So if you look at what we did with Llama, and specifically Llama 2, the fundamental responsibility that we feel is to accelerate the field while making sure we are doing it in an open way and making sure it's a multi-stakeholder, multi-party input that goes into testing these models, looking at the emerging capabilities, having a tremendous amount of impact for the world across all countries and all cultures, figuring out where things don't work, listening to the input, and making sure as a community we are pushing the capabilities forward. I don't think you can do it as one company. I don't think you can set rules as one company. I think you have to do this by bringing along everybody, by showing what works, what doesn't, by actually setting a strong benchmark of best practices, a strong benchmark of safety suites. If you look at the 70-page Llama 2 paper that we wrote, a significant part of the content is actually focused on responsibility and safety. The innovation that we have done in making sure the model is not just helpful, which is how we think of assistants today powered by these large language models, but also how they can be safe. What are the things we need to do on the pre-training data? What are the things we need to do on post-training and fine-tuning and alignment? What are the things we cannot do because we don't know how to do because it's an open research problem? And making sure that efforts like Purple Llama that we just announced is basically a combination of attackers trying to see how the models perform, what are the pitfalls, what additional measures we can do to mitigate them. So that's really how we think about the responsible angle of this, is like bringing along all of these stakeholders, making sure that the know-how is common across all of the folks in the companies, in the startup ecosystem, as well as governments and so on, and evolving it's a cutting-edge technology. Like somebody was talking about a new model that came up this morning. I was not surprised. There was a new model last week. There'll be a new model tomorrow. In that world, we want to make sure we are iterating quickly together.
Thank you. Ankita, coming to the question of, which is basic underlying factor of large language models is compute. And we all know it is a significant part. That's perhaps one of the things which actually, sometimes it is called a roadblock to, whether you can build a large language model or not. So what could be the new innovations and how innovatively we can tackle this problem? Everybody talks about having a very large compute and then going for a large language model, and sometimes then figuring out the use cases. All of that is some of the things which have been under discussion. So would be very keen to know your views on that.
Yeah, thank you. Thank you so much, Amit. It's a great privilege to be here, and it's been really great hearing your partners' insights. Before I get to the computational heft question, I do want to address one issue in developing countries where text data is limited, and I think that was highlighted. And so what is actually required is multilingual speech and translation AI software for building and deploying fully customizable, real-time conversational AI, including automatic speech recognition, text-to-speech, neural machine translation application that can be deployed in cloud, data center, at the edge, or on embedded devices. So that's going to be super critical wherever text data is limited, because all the models are as good as the data that's available to them. We at NVIDIA here always lead with the use case. And one of the use cases that my personal focus is contact center transformation. And contact center transformation across the globe for various industry verticals like retail, healthcare, telecom, financial services, and insurance. So starting with the use case is the right approach. That's what I would say. Now, going back to the question of computational heft for scaling with large language model, whether you are doing a research or you are an enterprise ready to deploy generative AI in production, you need to start with an innovative platform like NVIDIA AI Enterprise. NVIDIA AI Enterprise is not just end-to-end platform for deploying production-grade enterprise ready generative AI solution, but it's a lifeline of generative AI. It includes an AI software framework called NVIDIA NeMo, which really optimizes the training time and the resources that are required. So making it lean and less demanding on the precious available resources. At the foundation of NVIDIA AI Enterprise is an accelerated computing infrastructure. The accelerated computing infrastructure, you guys, is pivotal. Why? Because when our customers deploy it, they see the cost falling compared to it being prohibitive in the past. That's transformational, right? Because especially in developing countries, the financial resources can be scarce. So that's transformational. Then finally, the cherry on the top is the cloud-native software tools. These cloud-native software tools really make it easy to deploy. They simplify the deployment, opening up the doors and widening the access to AI. So that's another advantage of it. Now, I want to take a case as an example of a recent announcement that was done of TensorRT LLM inferencing speedup of 6.7x on H200 GPU on actually Llama 2 70B and the world's largest model called Falcon 180B. what we were able to show to the world was that what took 8 GPUs in the past, you can do that in one GPU, one single GPU. And that was all because of the TensorRT LLM inferencing speed up that an accelerated computing infrastructure can provide. But what's personally very meaningful to me as I work for this company is how NVIDIA is committed towards empowerment and education. It's all about making sure that developing countries are not just joining in, they are driving the AI revolution. It's all about making sure that we are nurturing the local expertise and making sure that they're not just participants, but the AI leaders and innovators. And that's the empowerment of NVIDIA AI Enterprise. And it's a powerful step towards making sure that our AI future is inclusive.
Thank you. So, coming to Professor Mitesh, you know, India is a country, and we heard all the panelists about, you know, different things, different points about a large language model. And India is a very diverse linguistic country, right? And preserving this diversity was one of the propositions through which, why Bhashini is there as a project as well. So what do you think, you know, India's strategy should be from a perspective of building a large language model and keeping the multilinguality aspect of it, you know, preserve the multilinguality aspect of it, and also go to multiple other activities which are...
Yeah, I think I'm audible. Yeah. Yeah, so now if you think of this Indic LLMs, right? Now, what do you mean by Indic LLMs, right? So I think they mean 3 things. Of Indian use cases, LLMs of Indian use cases, LLMs for Indian use cases, LLMs of Indian languages and Indian content, right? So technically it's a language model of something. So current LLMs are language models of English predominantly. We want language models of Indian languages and Indian content, and LLMs by Indians, right? And there's a lot of fanfare around this LLMs by Indian where statements get made, various controversial statements get made, and we pay a lot of attention to that. But in my view, we should focus on the first 2 also, which is LLMs for Indian use cases and LLMs of Indian languages, right? So let me talk about LLMs for Indian use cases. I think Rohini already touched upon that. Even today, it is possible to build something like a PM Kisan bot for a farmer who only speaks Tamil using all the open source technology that is available out there, right? You could use all the open source models that are available on Bhashini to act as language interface, the speech recognition, translation, speech synthesis, all of this you can use. And in middle, you could put any of your powerful open source LLMs like a Llama 2. And I'm focusing on Llama open source because I think in the government setup that is important, right? So Llama 2 is one, Mistral is another. Any of these permissible licensed models, you could integrate all of this together and make something like a Jugalbandi, which we have seen, or any of these government chatbots, or making people aware of schemes, something as simple as calling women who are pregnant and reminding them of the different medications and different checkups that need to be done, right? All of this is possible even today by integrating the language technology that we already have, right? So this is LLMs for Indian use cases, and this is where we should all put in a lot more energy and get more things running on the ground, because once that happens, and once people realize what we can do with this language technology, with this entire ecosystem of language technology, just the LLM just being in the middle, there'll be more interest in the other 2, which is LLMs of Indian languages. Because now we'll start realizing, hey, this does well, but when I ask it a question about the Kanda Poha ceremony, I don't know how many of you know about it, it's a ceremony in Maharashtra where the prospective bridegroom meets the prospective bride for the first time, right? And what is served is Kanda Poha, that's why it's called Kanda Poha ceremony. Now the GPTs of the world will not have this context, right? Because there's no Wikipedia page on this. There might not be blogs written on this. But I'm sure there are people who have written about this, have shared their experiences about that in the regional language. So that is what I mean by LLMs of Indian languages and Indian contexts, right? Indian content. And that is where we need to invest in the middle term, where we take a powerful LLM and teach it more about India instead of thinking about building LLMs from scratch, right? So that they get more aware of the Indian context, Indian content, Indian languages, today, one problem with GPT-4 and many of the other models, including Llama 2, is that suppose you ask it to answer in Hindi. It produces very good answers. I'm talking about GPT-4. But what you need to realize, like technical detail there is, if for you and me that answer is 100 tokens or 100 words, in GPT-4's interpretation, it is close to 1,000 tokens, because GPT-4 almost treats every Indian character as one token, right? And why is this important? This is important because we pay per token or pay per word of output getting generated, right? So if you're generating a 100-word output, which is reasonable, you asked it to write one paragraph on the Battle of Panipat, 100 words is reasonable, but you will pay for something like 1,000 tokens because it has not seen enough Indian language tokens in its pre-training data. The tokenizer does not have enough Indian language content. So that's why I mean by of Indian languages and of Indian content, where we feed in Indian data in Indian languages. So the native capacity of the LLM in these languages becomes better, as opposed to sort of taking the English route, or as opposed to treating them as languages which just have character level tokens, right? And both of these are important. So that's what we need to invest in the middle term, take the best open source model and add Indian language data to it and continually pre-train it. In the long term, what comes is LLMs by Indians, right? And once we have enough experience in the first two, we'll be able to talk about building LLMs from scratch in India by learning what are the applications that we really want to focus on. If I want to build an LLM, and the largest application that I have today is agriculture and health, I better have a strategy that I feed in a lot of data from Indian knowledge systems on agriculture and medicine into this LLM, right? Right now, just going out and blending in the blind, just collecting random news data from the web and trying to build an Indian LLM does not really cut it. It's too easy, too early to rush in to do that, right? And not just that, right? It's not just about building the models, but it's also about aligning the models, what you know as supervised fine-tuning. So the base LLM knows world knowledge, but then it has to be made better on certain tasks. What are the tasks that we care about? Do we care about tasks in agriculture, healthcare, STEM, education? If those are the tasks, then invest in collecting data for those languages. Ask Indians to collect data for those languages, as opposed to taking data from the West and translating it, right? So that is, again, LLMs by Indians, where we create our data, we decide what are the applications that are important, we build our models, and then align the models to our ethos and our culture and our preferences, right? Right now, the models are basically aligned to data collected in the West. Can we align them to Indian preferences? Then I'll give you an example, right? If it's a formal context, I would prefer ARP. If it's an informal context, I'm okay with 2. This preference has to be taught to the model, that if you're referring to Mahatma Gandhi, you have to say Mahatma Gandhi ji and unhone as opposed to usne, right? Which is not very respectful. This alignment to Indian culture is something that we Indians will be able to do, but that's in the long term, right? So again, summarizing, the short term is for Indian use cases, the mid term is of Indian languages and Indian content, and the long term is by Indians starting from scratch and thinking about things that we care about and build LLMs for those.
Thank you. Three-step approach, actually. Professor Mohit, you know, coming back and you heard all the panelists talk about it and the Indian context as such. What do you think the 3 areas of research which India should carry out towards the building scalable LLMs?
Yeah, I think I agree with a lot of what Mitesh said. I think, except maybe the third bullet, right? It may be it's not feasible or necessary, right, for every sort of group of users to build their own LLM, and then I'm focusing on the term from scratch, because I think we should be, like I said before, using a lot of resources already available to us. There's millions of dollars and 100 crores of rupees that might have been spent right very soon on different kinds of LLMs that already exist. And so my firm belief is being able to extract more emergent and unseen behavior from these language models, and you'll be surprised how it's not that hard to be able to make them do very different things. I'll give you an example. We had a recent work showing how you can take GPT-4 or any sort of strong, and we showed open source versions too, language models to create plans for long distance multi-scene video generation, right? So that was basically not foreseeable beforehand, because these models have not been trained on anything related to long multi-scene videos, but they have a lot of capabilities like being able to do co-reference resolution between scenes, right, and understanding which pronouns and nouns and entities refer to each other. Or they also understand things like prepositions, right, that if something is on top of the other, a cat is on top of a bed, then the bounding box or the segmentation for the cat, when it's generating that frame, right, should be higher in y coordinate than the bounding box of the bed. So we can use a lot of, this is for multimodal, right? Now for languages, we have a lot of power in joint representation spaces, right? So if we have built a large-scale language model which is already learning a joint space across several languages, it's very good at finding nearest neighbors, it's very good. And so like I said before, right, maybe we should be able to first see whether there's a multitask setting where it can understand a new scenario of a new language by combining existing right, sibling languages and neighbor languages, right, through the language tree, family tree. Or it could also go into the continual learning setup instead of multitask learning, where you actually keep giving it a little bit more data, but minimally, right, to be able to make it learn a new skill. And both of these, I think one thing that we haven't covered so far in the panel is the factor of efficiency. So we should not be trying to scale things unnecessarily, right? We should be actually forcing them to be as small as possible so that they could also run live on every villager's maybe 2,000 rupee cell phone, right? Which has minimal memory, minimal storage, and minimal sort of flops, which is the speed, right? So there's a lot of focus in the community on how we can basically do continual learning, multitask learning by very efficient methods like model merging or adapters or LoRa or quantized LoRa, sparsified quantized LoRa, right? Where the idea is that you try to insert very specific minimal modules into these models and only update those parameters to teach it new skills or new languages. Or you can basically try to merge vectors of existing tasks in a way that they can actually not lose their skills that they had learned previously, right, when they were trained from scratch, while also being good on new skills.
Right. I think a lot of insights there. Americo, what would be your thought on this? You heard us speak about a lot about India. I don't know how familiar you are with India, but multilingual. There is a digital divide, there is a literacy divide, yet we are looking at using technology for the benefit of the common man, the last mile. So what would be your thought and your takes on that?
Yes, so totally aligned with what Professor just mentioned. I'll add on this idea to make sure that we reuse what has already been created and try to be very lean. Making sure that we can operate in the cloud is inherently something that helps with a lot of considerations. Just prior to this session, we had a session that was tackling, for instance, the correlation between AI and the environment. And so indeed, kind of building an infrastructure just to train a model, it's like building a dam just to handle a spike of energy. I'll come back. I'd like to come back a bit on the cost. We mentioned cost a few times. I believe this is something that is super essential, critical right now. When we look at the way AWS customers are using their generative AI projects, they all started exploring, and all the solutions that have been described using proprietary models, using open source models, they work, they produce outcomes. Now it's very difficult to find outcomes that are economically viable. Customers are really struggling, making sure that the return investment, the cost just to inference with those models compensate the optimization, the operational efficiency that they are looking for. So I think those are the two dimensions that by the next month, the next year, I expect that the market and the communities also help to tackle.
Thank you. I think that's important. Yeah, you were wanting to say something.
Yeah, I wanted to plug for 2 points, right? One, if you go look at multilinguality, I think we should not underestimate the progress we made in translation. So And I'm saying this because we tested Llama 2 outputs, which are predominantly, obviously, a significant amount of tokens are English, but it has multilingual tokens. So what we did is, so we have this model called NLLB, No Language Left Behind, which we trained on 200 input and 200 output, of which 25 languages are actually Indian. This is text only. We were able to use that translation system for continued pre-training as well as fine-tuning on top of translation outputs. You take English fine-tuning data and you translate it using this translation model, and you train the original Llama model, and it does a really good job on these new languages. I don't want to discard low-hanging fruit efforts like those. And this is not just on text. We also talked about seamless models on speech, which actually support real-time translation of various languages. So that is ASR now that you can do, and TTS. So I do think there is an opportunity there, and people should experiment a little bit more, because translation has been something that has been worked for decades. So that's number one. Second, on inference cost, I think it's important to contextualize where we started. So if you look at where deep learning was with AlexNet model in 2012, it's a joke in terms of the capacity of that model now on where we can, how much compute we need to do inference with AlexNet model. That's 10 years. I know it's a long time, but given the acceleration of the field, I don't think it's unimaginable to see in a couple of years where the cost of many of these models go from these 7 billion high-capacity models to distilled versions, which could be in the order of 100 million model or 1 billion parameter model, where the cost significantly comes down, specifically when you start special purposing many of these models. I think this is a real test for our field, where one part of the field will push for this universality, generalization, because we want to go after AGI, general intelligence. And then this other part of making it work for specific use cases with the lowest amount of cost and efficiency in mind. And I think that duality is great for the field.
Yeah, that duality is great. And Rohini, you are doing many things in this field already. So what are your views, and how do we actually make the needle move as far as India is concerned?
So couple of observations. One, I think in the long term, I really do appreciate what Mitesh was saying, because I think it's a question of, if one is looking at whether you want to call it AGI or anything, if you're looking at AI having knowledge, intelligence of humanity, it's important that India's knowledge and wisdom and history is well captured in there. So that's a very high level comment, but I think to me that's important. But having said that, I think there is a lot of work that can happen in the near term in terms of bringing the benefits to people, whether it's education, healthcare, the patient-doctor ratio, the teacher capability, etc. There's tremendous opportunities to leverage this technology to bring benefits to the common person, along with Bhashini, along with the work on Jugalbandi, Bhashadan, many of these things that we are working on. So that's one. I think the overarching point that that Amitabh you talked about is the issue of emerging countries and very diverse, very culturally complex countries like India. I think that area is an active area of research at Microsoft. In fact, there is a project that's a multi-stakeholder project called VELLM, called Universal Empowerment with LLMs. It's actually evaluating every single model out there in terms of its accuracy, applicability, universality, for multiple tasks, complex tasks, simple tasks. So there is a lot of active research happening in that space, and I expect my research colleagues, and I'm sure some of them are working with Mitesh and some of the folks here, to continue on that. But I think an immediate output, like I said, we have to keep the long term in mind while we keep making some real impact on the ground in the short term. So one of the outputs from that work is being piloted right now, called Shiksha Copilot. It is being piloted in a few schools in Karnataka, wherein the co-pilot, which is think of it as an agent that's able to help teachers from middle school to create engaging, interesting lesson plans, for example, for their students based on the actual syllabus corpus, being able to create experiments, homeworks, etc. So really be a teacher's co-pilot to help them be more effective in their classroom. And that's one of the, I think of it as a short-term impact, while the longer-term thinking about how to make sure that the LLMs really are there for universal empowerment is an ongoing project.
Right. Ankita, coming to you, we talked about, going to the last mile, and Professor Mohit also talked about having efficiency on the last mile. What are the possibilities of GPU miniaturization to actually reach the last mile devices which are being used, maybe the smartphones and feature phones?
As it relates to LLMs?
Yeah.
Yeah, so, I will take an example of conversational AI pipelines. So we have, I talked about this, that we have an AI framework called NVIDIA Riva, which is a GPU-accelerated multilingual speech and translation AI for building fully customizable real-time conversational AI pipeline. And that software is actually available to be deployed on embedded devices. So scalability is super important. Efficiency is super important. And also making sure that we can deploy it, whether it's in cloud, whether it's in data center, whether it's at the edge or on embedded devices, is going to be super critical, especially in developing countries, where, like I mentioned, the financial resources can be scarce. So having that adaptability is super critical in order to scale. Did that answer your question?
Yeah, that's
Okay,
some way, yes. But yeah, it was a quite futuristic question also. That's fine. Vinod, coming to you, when we are talking about India, multilinguality, ethics, responsible AI as such, what's your thought process on, how should India proceed when we are trying to build up a LLM or, adopt a LLM, or the step-by-step approach which Mitesh talked about? What are the boundaries, guardrails which we should be drawing upon?
Yeah, thanks for that question. I think, we talked in the panel, we talked about various kind of gaps that needs to be filled in terms of equitable sort of capabilities in like different languages, about sort of access to technologies like the digital divide and the literacy divide that you talked about earlier, as well as like various sort of fairness, bias issues that these large language models often have, like that may propagate sort of societal biases that are existing in the data sets. For instance, like in one of the recent work that we analyzed, like some of the large language models to actually tell a story or write a story about like a girl going to Paris versus a girl going to Ghana in Accra, Accra in Ghana. And like the story of the girl in Paris is about like, going to museums and like, arts, culture, all sorts of things. Whereas like the girl, I think it was a boy, was like playing some sports in like a dirty sort of playground, and then like an American kind of non-profit person came and like gave him education, like gave him money to go get education. That was a story that was sort of like that the LLM decided to tell. And this shows like the deep sort of like biases, societal biases that are reflected in the data sets that are being captured as knowledge. It is some sort of social knowledge, but that's not the knowledge that we necessarily want to propagate. And so when we talk about like responsibility, often people don't go beyond like defining what that means, and often it ends up being talking about safety in a sort of like offensive language kind of context, which is also a very challenging problem. But there's all these other aspects of responsibility that should be looked into. And to solve that, like the way I think about it is, or people that I work with, our team think about it is to sort of not think about it just in terms of multilingual technologies, but rather multicultural technologies. It's not just a matter of throwing a lot of like data in a new language into like these models and like sort of figure out that it would just like learn to sort of like engage in that like cultural ecosystem. You need to take into account the larger cultural ecosystem within which those language communities operate, the cultural knowledge that is needed to operate that, and also the cultural values and norms that we incorporate into these models. And in terms of the approaches or avenues of sort of intervention there, I think there's a lot of avenues are in terms of data. Like we talked about it, so I wouldn't go into much detail, but I do want to make the distinction between training data, which is what a lot of us talked about, but also evaluation data, which is like super important in this context. And evaluation data means that you have to sort of like build evaluation, not just in terms of capabilities of certain tasks, but also like the sort of responsibility or fairness, social sort of like tasks, like or sort of like how much these biases are propagated and so on. For that, you need like societal knowledge like on various socio-cultural contexts. And there are various approaches that you can do, and our team has been working on like building, even in partnership with LLMs, like you can use these large language models to build those broad coverage resources that can then be used to evaluate these models. Because like the way of like building evaluation data by just like hiring like a dozen annotators and like, you know, human annotators like would be the answer. Those days are past, I guess, because each human annotator or each human labeler brings a lot of sociocultural sort of knowledge into their like into their labels. So whenever large language models, any model capability, people talk about it in terms of, oh, we have matched like human capabilities or human performance. I'm like, which human are you talking about? Like humans are not interchangeable. So building evaluation resources that are multicultural, that have multicultural representation is also important. And yeah, I'll wrap up there. So there's like, and in doing that, so they're like LLM based, or like you can do it with in partnership with LLMs to like have better coverage for this societal knowledge, but of course with like social validation, socially situated validation, but also community engagement. Like we recently have a paper actually tomorrow. Day after tomorrow, I'll be presenting it at NeurIPS, if I get there, which is where we built a data set of social stereotypes that exist in India through a community-centered collection of like from hundreds of people from various 8 or 9 universities across India to build that resource, rather than just like recruiting like, say, a few human annotators to do that. I'll stop there. Thanks for the question.
Thanks for that insight. Just I would like to wrap this session up by, you know, inviting one-liner comment if you have to take, and I know it's difficult, but if you have to choose one such parameter, like what should be the core of building large language model is, if I can start off with you, Mitesh.
One word answer, data.
Trust.
Do it in the cloud.
I said one sentence, I think making it work for the world.
You caught that. Being globally responsible.
I think you said one line, didn't you? So generative AI is not a buzzword, you guys. It's real. And if you sit this one out, you're going to fall way behind in the market with respect to cost and innovation. So let's do this.
I think, just very strong optimism with just very strong carefulness, right, about things like responsibility, bias, and then the other thing I would repeat is efficiency, all kinds of efficiency, data efficiency, parameter efficiency. That's the way to make it accessible to everyone.
Right, I think, you know, the last round of, you know, one word or one sentence covers it all, and it, you know, gives you an insight that we need data, we need trust, we need to be responsible, we can't be left behind, we need to be efficient, and of course we need to be on a scalable infrastructure like cloud, which is there, and of course be responsible about it. So, you know, gives you a summary of what we are. Thank you very much, all of you, for making the time out for today. and also giving us this insight. It has been wonderful discussing this topic with you. Thank you.
Thank you.
We could just stay on for some time.
Yeah, we have some souvenirs as a token of our appreciation for your time and effort. So I would request Amitabh sir to please hand it over to our panelists.
Amazing. Thank you so much. Thank you. You are amazing. You're great. Thank you so much. Those were some great insights. Thanks a lot. Nice meeting you too. Thank you so much. That's so good. Well, you're really spoiling us here with gifts. It's like Christmas.
Okay, sir.
Let's connect on LinkedIn.
बैकड्रॉप जो है वो लगा दें